Hello my dear students, good morning to all of you. In today's session we will discuss about the photoionization process. Okay, here in previous session we have already started with the ionization processes, right? So in that ionization process are of four types are there. Which are those? The first one is ionization by collision, and the second one is photoionization, and third one is secondary ionization processes, and fourth one is electron attachment process. Okay, in that ionization process is only the first one is by collision, so that we have discussed in the previous class, right? In today's session we will move on to the second process, that is what? Photoionization process. Okay, so first we try to understand the terms what are there here. Photo, it is nothing but what? It is the light energy. After the using this light energy, ionization process it is going to be takes place. How that process will takes place, we'll see. Okay, first basically I need to clear one thing here. What is ion? Ion means what? Ion, it is nothing but an atom or a molecule. So ion is nothing but an atom or the molecule that will be having a net electrical charge. How it will be having net electrical charge? Due to the loss or a gaining of one or more electrons. So that is going to be called it as a ion. Then what is ionization process? What is photoionization process means? It is nothing but the physical process in which ion it is going to be formed. How ion is formed? There should be some interaction, right? Then only, if there is an interaction, then only the gaining or a losing of the electrons will be there, right? So the photoionization process, it is nothing but here in which ion it is going to be formed due to the interaction between the photon. Nothing but the photon, it is nothing but a packet of energy. Getting my point? From the interaction of photon with an atom or the molecule. Let us consider here two electrode system. How many electrodes are there here? Two electrodes. One it is anode and this is the cathode. Okay. In between these two electrodes there is a small distance that is denoted by how? Small d here. Getting my point? So after this, see here, on this cathode light energy it is going to be incidenting on this. Is it right? So which light we are passing on the cathode here? That is ultraviolet radiation which is falling on the cathode here. So let us consider. After this is the adjustable high voltage source is there. When we apply a voltage to this electrode system, then what will happen? The electrons are going to be starts moving towards here itself. The electrons, once after the application of a voltage to this two electrode system, the electrons are going to be starts moving from cathode to the anode itself. Is it right? So these electrons, what they will do, the charged particles or the electrons gets energized with the help of this light energy. Getting my point? These electrons are going to be completely absorbs the light energy. Which light? Ultraviolet energy. Light energy, it is going to be absorbed by the electrons. Then next what will happen? The energetic electrons then collide with what? Here in between these two electrodes, which medium will be present here? That is gaseous medium. For example, what we had considered for the gaseous medium? That is air, right? So here the gaseous atom or the molecules gets interacted with the energized electrons, then leads to what? Ionization process. Getting my point? What is that ionization process? Ionization process, it is nothing but an atom or a molecule which gains the positive or negative energy, which gains the energy. How it is going to be gaining? Or by losing or gaining the one or more electrons itself. Is it right? So now here the electrons are going to be, when we apply the voltage, the electrons are going to be starts moving from cathode to anode here. But before here the electrons, it is completely absorbs the light energy, then gets energized. Is it right? The energized charged particles interact with the gaseous molecules. Getting my point? So How the photoionization takes place. The photoionization process occurs when the amount of radiation energy absorbed by an atom or the molecule, if it is going to be exceeds its ionization potential. Getting my point? Ionization potential, it is represented by V suffix I. When if it the absorbed energy by this electron, if it is going to be exceeds the ionization potential, means then only photoionization process takes place. Getting my point? So next what I told, what is there here? The atom or the molecule which absorbs, here the electrons, it is going to be absorbs this light energy and gets energized, right? So this absorption process, how it is going to be achieved? But there are several processes are there. Which are those? There are several processes by which the radiation, means what? That is light energy. Which light? Ultraviolet, which is falling on the cathode, can be absorbed by an atom or the molecule. By which processes? These are the two processes will be responsible for the absorption of radiation energy by atoms or the molecules. The first one, which one? That is excitation of an atom to a higher energy state itself. So first, what is that process? Excitation process of an atom to a which energy levels? We know that energy levels of the atom or the molecules, lower energy level, higher energy level, or lower energy, it is going to be considered as a ground level. Is it right? So we have studied in the physics also. Here, excitation of atom. What is that excitation process? Excitation, it is nothing but the energy which is being given to electron. Getting my point? Once we apply the voltage here, the electrons are going to be starts moving from where? From cathode to anode itself. These electrons are going to be gets which energy? Which energy they are going to absorbing? This is light energy, right? After absorbing the light energy, they are going to be gets excited. Nothing but when they are going to excited and then reaches the higher energy levels. Nothing but what? Excitation process. Keep it in mind, excitation, it is nothing but the energy which is being given to the electron. Which energy which is being to given electron? That is light energy. When it is moving towards what? The higher energy levels. Getting my point? The first process which is responsible for the absorption of light energy by the atoms or molecules. What is that process? That is excitation process. Next one here. Excitation process means it will reach to the higher energy level, or else it is going to be continuous absorption process. Continuously it is going to absorb the light energy by the atoms or the molecules. Getting my point? There are two processes, you just keep it in mind. The first one, it is excitation of the atom to a higher energy state, and second one is continuous absorption process. Just this much you need to remember. Okay. Next we will move on to here. Suppose an excited atom. Excited atom means what? It's already reached its higher energy level. Once it reaches its higher energy level, nothing but completely electron or the atom or the molecules, it's absorbed the light energy completely. Then it gets energized charged particle. Getting my point? Once it's reached its higher energy levels, it starts emitting the radiations. Just as an excited atom, it emits the radiation. When it will emit the radiation process, emitting process, when it will takes place means when the electron returns to the lower state or to the ground state. Keep it in mind. Excited atom, excitation, it is nothing but the absorption process of the light energy and get excited to a higher energy level itself. This excited atom, when it will start emitting the radiation means what? The electron should returns to the lower state or to the ground state. Getting my point? So it is nothing but what? The reverse process takes place. Is it right? Reaching to the higher energy level, then it comes to what? Lower energy level. Nothing but it is what? Reverse process takes place, or nothing but the emission of radiation takes place. Is it right? The reverse process takes place when atom absorbs the radiation. This reversible process, how we can express means by this formula. What is there? H nu plus A this is gives to the reversible process. Both the directions it will represents the here excitation process. Here excitation it is nothing but the absorption of light energy. Next it is reaching to the lower energy levels means nothing but emitting the radiation, absorbing the radiation, emitting the radiation, nothing but reversible process takes place here. So H nu plus A, this will give the positive ion here. Getting my point? H nu it is nothing but what? That is H it is nothing but the Planck's constant and nu is nothing but the frequency of incident light itself. Getting my point? So this H nu when it is interacted with which atom? That is gaseous atom or the molecule. This will give what? Ionization, that is positive ion it will give, right? Where H is nothing but what it is? Planck's constant. Planck's constant, what is the value of Planck's constant? That is 6.626 into 10 raised to minus 34 meter square kg per second itself. And this will be the H nu, it is nothing but the, that is frequency of incident light itself. How will write this one? E is equal to H nu is there. H nu we can write it like a H nu divided by lambda. H C divided by lambda. So V frequency it is nothing but frequency instead of this frequency, the velocity of the light we have to consider. So E is equal to H nu. Energy it is nothing but light energy. So when it is interacted with the neutral gaseous molecule or the gaseous atom, this will give the positive ion over here. Getting my point? So next thing here, when ionization process takes place, photoionization process, when it will take place? Means when the amount of radiation energy which is absorbed by an atom or the molecule, if it is going to be exceeds its ionization potential, means ionization process takes place. In that case, how will write? Lambda. Lambda it is nothing but the wavelength of incident radiation. This will be less than equal to C into H divided by V suffix I here, where C is nothing but the velocity of the light. What is the value for velocity of light? That is 3 into 10 raised to 8 meter per second. And H is the Planck's constant. What is the value of Planck's constant? 6.626 into 10 raised to minus 34. And this V suffix I, it is nothing but the ionization potential. Getting my point? As the wavelength of light, if it is going to be increases, means this potential, ionization potential, it is going to be decreases. Obviously, when the photoionization process takes place, only the amount of radiation energy which is absorbed by an atom or a molecule, if it is going to be exceeds its ionization potential, means this process it is going to be takes place. Getting? Where H is nothing but the Planck's constant, C is the velocity of the light, lambda is the wavelength of incident radiation, and Vi is nothing but the ionization energy of the atom. Now what we have to do, substituting the values for H and C. H is nothing but Planck's constant and C is the velocity of a light here. So what is the value I told for this H and C? C is nothing but C is equal to what? 3 into 10 raised to 8 into what we have to do? Just you substitute the values here. C means 3 into 10 raised to 8 and Planck's constant is 6.626 into 10 raised to minus 34. After calculating, you will get the value as a lambda is less than equal to 1.27 divided by ionization potential, that is Vi, into 10 raised to minus 6 centimeter. We will get this one. Substitute the values for Planck's constant and the velocity of light. Okay. Next, I hope this is clear to all of you. So this is all about what? Photoionization process. Next, what we are having? Third process, that is secondary ionization processes. Secondary ionization processes means there are three types are there. The first one is electron emission due to positive ion impact. Getting my point? So the positive ion impact, nothing but what? These positive ions are going to be formed due to the ionization by collision process. We already discussed about the ionization by collision, right? So the electrons are going to be gets emitted due to the impact of what? Due to the incidenting of the positive ions. These positive ions are going to be formed due to the processes are going to be called it as ionization by collision process or with the help of the photoionization process. So already I have shown here, this is nothing but what? This is positive ion itself. With the help of the photoionization process, the positive ions are going to be formed, or else the positive ions are going to be formed with the help of the ionization by collision process. Whatever the positive ion we get from those two processes will impact the using this positive ion, we can what? The electrons are going to be gets emitted. First one is electron emission due to the positive ion impact. Keep it in mind, the positive ions how they are going to be formed means due to the ionization by collision or with the help of the photoionization process. Getting my point? So these ion, it is being positively charged itself. From how it will travel? It will travel towards the cathode. Keep it in mind. Anode, it is nothing but positive. Cathode is negative. Obviously, right? This is positive means it will travel towards cathode or anode. It will obviously, it will travel towards the cathode because negative it is. Obviously, opposite charges attract each other itself. Is it right? So that is why the electron emission due to the positive ion impact. So these positive ions from which process will get the positive ion from the ionization by collision or by the photoionization process. So these are being positively charged. That is why these positive ions are going to be travel towards what? Either to the cathode or one anode. Obviously, right? Anode is a negatively charged and cathode is anode is the positively charged, cathode is negatively. Then this positive ion, it will move towards or travel towards what? Obviously cathode, right? So it will move towards the cathode. Getting my point? Next here, a positive ion which is approaching to the metallic cathode can cause the emission of electrodes. So just we'll have here. So first what I told here, a positive ion, A plus what I told here, a positive ion is approaching to the metallic cathode. It does not move towards the anode. Why? Because it is positively charged, because opposite charges are going to be attract each other here. Then obviously that positive ion will move towards what? Cathode only. Then when it is going to be positive ion, when it approaching to this metallic cathode electrode, then it will cause the emission of electrons. How it will emit the electrons means by giving up its kinetic energy on its impact. Getting my point? So this positive ion starts moving to the cathode and it will emit the electron. How it will emit the electrons? By giving its kinetic energy due to the impact of this positive ion. Getting my point? Now, if the total energy of this positive ion, namely it is nothing but the sum of kinetic energy and the ionization energy. If it is the positive ion energy, the total energy of the positive ion, which will be the sum of what? Its kinetic energy and the ionization energy. This energy, if it is greater than the twice of the work function of this metallic cathode means, then only one electron will be ejected. Getting my point? So what I am telling here, it is very important. If the total energy of the positive ion, it is nothing but the sum of kinetic energy and the ionization energy. This energy, if it is greater than the work function of this metallic cathode, then only one electron will be ejected. Getting my point? And second electrons will neutralize the ions. Getting my point? So the process of whatever the electron ejected from this process means due to the positive ion impact, the probability of this process, it is going to be measured as the psi I itself. So this is going to be called it as a Townsend secondary ionization coefficient. Getting my point? So that process will explain in detailed manner in next class. So this is all about what? A positive ion impact. Due to this effect, electrons are going to be gets emitted. So second process is electron emission due to the photons. Obviously using the light energy, If it is going to be falling on the cathode, electrons are going to be gets emitted. Next one, electron emission due to the metastable and neutral atoms. So these processes will discuss in detailed manner in next class. Okay, I hope this is clear to all of you. Thank you.